Hi everyone, today we're going to be looking at shapes and angles. So here we have three triangles. What would you call these? So we notice the first one has all three angles smaller than 90 degrees. So we call this triangle an acute triangle. The next one has an angle that is greater than 90 degrees. So we call this an obtuse triangle. And lastly, it's a little bit hard to see and it's missing the symbol, but that bottom corner there should be a right angle, and if it is, we would call it a right angle triangle. So we always put that symbol in there so that we know that it's 90 degrees. How do we name these three triangles? The first one here in yellow has three angles that are all different, so we call this scaling. The second triangle, the white one over there, has two angles that are the same, so we call this isosceles. And this one here has three angles that are all equal, and it is called equilateral triangle. Here we have a triangle with angles A, B, and C. What happens if I rip the triangle into three pieces and put the three angles together? What would it add up to be? We notice that it always adds up to be a straight line, or in other words, 180 degrees. We can represent it by writing A plus B plus C equals 180. Or in other words, we can say the interior, the inside angles of a triangle totals 180 degrees. Now you might see this summarized in textbooks as the interior angles of triangles adding up to 180 as angle A plus angle B plus angle C equals 180. So they use this angle symbol here. More accurately, you'll see that it's angle CAB, angle ABC, and angle ACB. To clarify, angle CAB, means this angle here. So the middle letter is the angle that we're talking about. So if we only need the middle letter, what's the point of having the two letters on the side, you might wonder? Well, if we had a different shape, for example, and we had that vertices or corner that we were referring to, we have to specify which part of the angle we're talking about. For example, if I wanted the whole angle, so this CAD, then I would have those three letters. And if I wanted this side of the angle, in other words, just from B to A to D, it will look like so. So therefore you can see that it's important to have three letters, the middle letter being the corner or vertex that we're talking about, and the two other letters refer to which lines they are connected to. So we have summarized that the inside angles of a triangle or interior angles add up to 180. How can we use this? So here we have an example, 60 degrees, 80 degrees, and an unknown x. How would we figure it out? So we know all three add up to 180. Therefore, all we have to do is add up these two. 60 plus 80 is 140 degrees. And now we know that 180 minus these two, or 180 minus 140, is x, which is 40 degrees. Now looking at this triangle, we notice that there's these three little lines which indicate the three sides are the same. Or in other words, this is an equilateral triangle. So the three angles are also the same. So we can represent it as angle CAB equals angle ABC equals angle ACB. Therefore, x plus x plus x is 180. Or in other words, 180 divided by 3 equals x, which is 60 degrees. What about this one? Now we have a right angle. So here we have 90 plus 35 plus a equals 180 degrees. So 90 plus 35 is 125. 180 minus 125 gives us a, which is 55 degrees. Here we have an isosceles triangle. So these two sides are the same, and so therefore this is 70 as well. So in other words, these two angles add up to be 140. So what do we have left over? 180 minus 140 is going to give us x, which is 40 degrees. Here we have a triangle with three different angles. Now remember that the total of a straight line always adds up to be 180 degrees. So let's have a look. If I extend this line and make it a straight line, then we know that this section is going to add up to 180, or in other words, this is 70, this must be 180 minus 70, 110 degrees. What do we notice? We notice that the other two angles also add up to 110 degrees. Let's try another angle. Let's say we extend that side this time. What's 180 minus 30? 150 degrees. And does it add up to be the other two angles? Yes, it does. Because after all, it is a triangle and they have to add up to 180. And one last check. One last one here. So what number adds up to be 180? We need 100 degrees here, which is again the sum of the two other angles. So we can say that exterior angles of triangles are the sum of the other two angles. So you add up the other two to get your outside angle. Let's do an example. Here we have X, which is an exterior angle, and we have an angle inside, a 90 degrees and 35 degrees. So we know that the exterior angle adds up to be these two together. So 35 plus 90, which is 125 degrees. So X is equal to 125 degrees. Let's quickly revise quadrilaterals. Quadri as in four and laterals, side. So four-sided shapes. Do you remember what these are called? So we have the yellow one is a rectangle, the blue one is a trapezium, the peach one is the parallelogram, and the gray one is a rhombus, and the pink one is the kite. You will see in textbook that we use these symbols here to represent their lines which are parallel to each other. Let's study this shape here. Now there's a transverse going across two parallel lines. Now we notice that the top angle is bigger than the bottom angle, and the more we flatten the line, the bigger the top angle and the smaller the bottom angle. Now recall from last lesson that anything in a straight line adds up to 180 degrees. So we know that the one blue and one pink equals 180, or in other words, the inside angles add up to be 180. So the co-interior angles will total 180 degrees. Let's have a look at this trapezium. Now, it has two parallel lines, and I can draw a transverse line over there and over there. In other words, we have straight lines, and therefore we have two sets of 180 degrees, or two sets of angles that add up to 180 degrees. So these two on the left add up to 180, those two on the right add up to 180. Not together though. This time I've drawn the transverse as a complete mirror of each other, and therefore not only do they add up to 180, it is also called an isosceles trapezium because we have matching angles. So the two bottom yellow angles are the same and the two top ones are the same. What about the angles in a parallelogram? Now if we draw them out, we can see that again they add up to 180. Any neighboring two, so this one and that one, or that one and that one, or the top two or the left two, any neighboring two add up to 180. And the word for neighbor in maths is adjacent. So each adjacent pair of angles adds up to 180 degrees. What about a rhombus? We can see that's exactly the same as the previous shape. The neighboring angles add up to 180 degrees. See, there's a grey, a yellow, grey, yellow, grey. So as long as it's two next to each other, they add up to 180 degrees. And the diagonals are the same. What about this square here? What happens when I pull it out? We get a kite. And we notice that when we did that, the two angles on the side became bigger than the 90 degrees, but the angle in the middle became narrower or smaller. Here's three sets of kites to show you that these two angles are always matching. Kites are symmetrical and the diagonals, the red lines here, are always perpendicular to each other, or in other words, they always form 90 degrees. So let's summarize all the properties of these quadrilaterals. Quadrilaterals are things with 4 straight sides. We can have things that have 2 pairs of equal adjacent sides or 2 pairs of equal sides next to each other, which are kites. We can also have 4 equal sides, or 4 of them to be equal, which then would give us a rhombus. So these are all quadrilaterals. Another type of quadrilateral can have a pair of opposite parallel sides, and that is the trapezium. Now, if it has 4 straight sides with 1 pair of opposite parallel sides and 2 pairs of equal parallel sides, we call this a parallelogram. And if it fits all these 3 requirements and it has 4 equal angles, that would be a rectangle. And if it has all these attributes, so 4 equal angles and 4 equal sides, you've got a square. So this setup can help you see that a square is nothing more than a fancy rectangle, and a rectangle is a fancy parallelogram, and all these shapes are all quadrilaterals. Let's look at the word polygon. So the word poly means many and gon is angle. In the next slide, we're going to focus on polygons that are regular, and we're going to focus on interior angles. We're not going to look at exterior angles. Firstly, I want you to think about this triangle here. We know that 3 angles add up to 180 degrees. What about something that has 4 sides? Well, we can split it in half and we can see that it's made out of 2 triangles. One side adds up to be 180 and the other one adds up to 180. We can say that it adds up to 360 degrees because we can just add them together. What about pentagons? Things with 5 sides. What about pentagons? Well, we can cut that up and see that there's a triangle there, so we know these 3 angles add up to 180. And we can cut it up again and see that that total of all the angles will be 3 times 180, which is 540 degrees. Let's draw a table and summarize the sum of all the angles in each shape. The first shape we had a look at was a triangle. It has 3 sides and it's made out of 1 triangle, and the total of the interior angles is 180 degrees. So all the angles inside add up to 180. The next shape we had a look at was a square or rectangle or any 4-sided shape. And these quadrilaterals had 4 sides and it can be cut into 2 triangles. So the total interior angle was 360 degrees. Now let's look at more shapes and see if we can find a pattern. For pentagons or shapes with 5 sides, we have 3 triangles, which means the total of interior angles is 540 degrees. A hexagon, which has 6 sides, can be cut up into 4 triangles. In other words, the total of the angles is 720 degrees. So for any polygon, we can figure out the sum of the angles by taking n, the number of sides, minus 2 times 180. Let's calculate a few more angles. Here we have a 4-sided shape, and we know that that adds up to 360 degrees. So firstly, let's add up these 3 values. So 120, 180. A good way to do this is always start next to the thing you're looking for and then keep going around so you don't miss any value. Now these 3 add up to 300 degrees. And the last angle, we know that's 360 minus 300, which is 60 degrees. What about this octagon? How do we figure out the angle T? So we have the formula of the number of sides, which is 8, minus 2 is 6. 6 times 180 is 1080. And that is the total of all the angles. To find one angle, we take the total, 1080 divided by 8 to get 135 degrees. So T is equal 135. What about this shape? It's got 5 sides, so applying the same formula again. 5 minus 2 is 3, 3 times 180 is 540. So the total adds up to 540. Now we have to be very careful, there's a lot of numbers. So we're going to go around this way and not miss anything. So 540, take away 125 plus 100 plus 95 plus 100. And that gives us 120 degrees. So don't forget brackets in your calculator if you're using one. Otherwise, you're going to have minus that and then plus the rest, which would make it very inaccurate. One more. Here we have 1, 2, 3, 4, 5, 6 sides. So 6 minus 2 is 4. 4 times 180 gives us 720. So the total is 720. So again, we take 720 minus the total. And again, I've gone 140 and then 160, 70, 150, and 80. So see, I've gone all the way around so I don't miss anything. Try not to go in a random order, otherwise you're very likely to accidentally repeat a number or skip a number. So now that is equal to 120 degrees again. So Z is 120. So try your best to remember this formula. The number of sides minus 2 times 180 gives you the total of the angles. One more time. The number of sides minus 2 times 180 gives you the total of the angles. That's it from me today. See you next time.